Keeping up with security issues across thousands of web assets without the right approach to web application security is a daunting task. Get ahead with web vulnerability scanning automation from NetSparker, a leader in dynamic and interactive application security testing known for its ease of use and accurate results. Detect a wide range of vulnerabilities in all legacy and modern web applications, address security bugs at scale by automating the confirmation process, automatically prioritize vulnerabilities, and assign actionable tickets to the right developers in their native workflows for rapid remediation. For more information on how to scale application security with ease, visit securityweekly.com/NetSparker. Welcome back, everyone, to Paul's Security Weekly. SE Media debuts its all-new SE digital experience, fully integrated with Security Weekly podcast content and more. The new site increases the scope and scale of original content resources from editorial staff, contributors, and the far-reaching Cyber Risk Alliance network. Visit semagazine.com to check out the new look. Even though we don't have an actual magazine, it's digital right at this point.
It's an e-zine. As the kids,
right?
As I was going to say, as the kids used to say, no,
as us old folks call it.
Yep.
Joining us for this segment is Kyle Avery. Kyle is a penetration tester with a lifelong love for tinkering with computers. His hobbies include Hack the Box, home labbing, and catching the latest InfoSec drama on Twitter. Today, he joins us to discuss offensive operations with Mythic. Kyle, welcome to the show.
Hey, thank you.
Kyle, it's nice to have you. How did you get your start in information security?
Well, so my dad actually works in information technology. He works in infrastructure, servers, and storage. And so growing up, we've always done computer projects at home. For a long time, we had Active Directory and roaming home folders and all these things where you could sign into any computer in the house. And so just growing up, I've kind of always been into just general IT and things like that. And then as I kind of got older, I grew to get more into pen testing and offensive security. And so now that's kind of what I focus on.
And how did you meet up with John and the Black Hills team?
So kind of funny story. I started there as an intern originally. And so I was just sort of browsing Twitter, as you kind of mentioned I do. And I think it was Marcello, Pipe Leader. He posted that they were hiring interns. And so I sort of just raced to send him a message and did this sort of interview and got in that way. And then when I was ready to graduate school, they brought me on full time.
That's awesome. Do you live in the South Dakota area or do you work remotely?
I work remote. I've never even been to South Dakota, actually.
Gotcha.
I'm going in September
for the conference.
For Deadwood finally.
Yeah.
But yeah, I live in Texas, so I'm nowhere near there.
Gotcha. Well, that's awesome.
I'm kind of curious. You got an early start. Do you feel that having all that tech in your house and having parents that kind of facilitated some of that, do you feel like that pushed you more into technology, or do you feel like there are times that also causes you to go the opposite way?
Sure. Yeah. So, I mean, it definitely helps push me in this direction, right? I mean, growing up, it was hard to imagine doing much else just because that was like the thing that I knew how to do. And it was really fun. I've never been bored with it or tired of doing it. And so that was always sort of a good quality to me. But I looked at some of my friends and things that went into careers that were unrelated to what their parents did. And, it made me start to sort of wonder at times, I wonder what else I maybe would have done otherwise. But I really can't even imagine doing anything else because A, it's super fun, and B, it's just what I've always done. So.
Yeah, I found, with 3 kids at home, and I think many of us have the same experiences that it doesn't matter how much or how little you push your children in a certain direction to get interested in something. Like you, Kyle, if they're going to be into it, they're going to be into it, right? And you give them that environment. I mean, all my kids have computers and tablets. It's available to them. If they want to latch onto it, great. They want to do something else, great, right? I'm not going to, I can only slightly influence that. I can make it available, and then it's basically up to them. So good for you for latching onto it. Because I've got, Jack that worked for us for a while. Yeah. He was one that just latched onto it, right?
Yep.
His brother, not so much, but nothing wrong with that.
And brings whole new, thought to the, some of the best pen testers we've seen spent their lives growing up in infrastructure and Active Directory and networking, and like this brings a whole new spin to that growing up into and now becoming a pen tester. And
because like growing up for us was like we had to build the one computer in the house,
or we had to manage DNS and DHCP in an enterprise network for 6 months because no one else would do it.
Right.
And
yeah, today it's different.
Yeah,
all good though. Kyle, tell us about Mythic. How did you find Mythic, and what is it?
Yeah, so Mythic is, at least it's a C2 framework, a command and control framework. And so if you're familiar with like the C2 matrix, that's like an effort from, I believe it's associated with Scythe. I'm not sure if it's like formally, but it's basically an effort to sort of catalog all the different command and control frameworks. So, I mean, Cobalt Strike and Metasploit and Empire and dozens more. And so through some just internal projects at work, we were looking for, a tool to fill a certain void. And that's where I came across this. And ever since I found this and then have kind of been working with it, it's definitely just been like one of my favorite tools that I found.
I've always wanted to write one. Like I did a bunch of Python development, like hard and heavy for a while. And I was like, I'd love to write a C2 framework. And then, you click what is Mike Poor's expression? You click your heels twice and you Google search for it, and at least 3 other people have already done it, right? And so when I saw this was Python C2 framework, I'm like, yep, someone's already done it. I'm like, that's cool.
Sure. And the cool thing about Mythic is that, as you'll kind of see, is it's sort of meant to help you build your own piece of the framework. So it sort of like does a lot of the work for you in building your own framework, but still gives you quite a bit of control on pieces that you'd like to make from scratch. And so that's where I think it's really useful is that it sort of saves a lot of development time from making something like that from scratch.
Yeah. And it's all the modules are written in Python?
So all of the like server side code and sort of the like back end is primarily Python. Yeah.
And you did you develop a new wrapper or module? What do they call it?
So there are a bunch of different things in Mythic. One of them being wrapper payloads, and I'm going to get into that. But yes, I recently released a wrapper payload for Mythic. Just on Monday, I put out a blog post about sort of a use case of Mythic that I'm going to talk about. And I've been working on a few other things as well that I hope to release in the upcoming weeks, I guess.
And do you write those in Python, or do you write the payloads in a different language and they just get delivered through the Python framework?
Right. So the Python components are sort of the bits that interact with the Mythic core server or with, the Mythic web interface. But you can write the payloads or the wrappers or the network profiles that I'm going to talk about in really any language. It doesn't matter. As long as you can interact, as long as you can have these sort of Python scripts that define and sort of maintain these things that you write.
Gotcha. Awesome. Well, you got some slides, so let's dig into it.
Yeah. Let me switch over here. All right. Can you guys see that?
Yes.
Great. So like we've already said, I'm talking about offensive operations with Mythic. So just a quick little thing. I know I already sort of introduced myself, but I'm a pen tester and a developer with Black Hills. I'm also an instructor with Wild West Hackin' Fest. I put my Twitter and GitHub there, so feel free to follow those. So just a quick agenda. I'm going to start off with...
Kyle. So which class are you teaching for Black Hills?
Yeah, I teach Windows post-exploitation, and so the class is all about what to do once you've established your C2 or gotten your sort of shell in the environment, what to do next, and how to kind of get from that initial access to whatever your goals are.
Sweet.
So, back to the agenda, I'm going to talk about what exactly Mythic is, a little bit about what makes it unique, although that's kind of what the whole presentation is going to be. We'll talk about some payload types, which is the actual implants themselves and how you can modify those for your own uses. We'll go into what exactly wrapper payloads are and how you can make those. I'll touch on automated deployment to sort of speed up using Mythic and getting started. And then finally, I'll just talk about like what I think some practical use cases are and how Mythic in particular solves some problems that other tools don't. So we'll jump into the overview. So kind of like I said, Mythic is a C2 framework. it does all the things that a C2 framework does, but it also does many more things. So some of the sort of like highlights, I guess, each implant that you use in Mythic, and you'll see that there are many kinds of implants publicly available or that you could make yourself. Any kind of implant you use in this framework has these sort of very customizable build environments. So we talked about these Python scripts that you can use to sort of interact with the Mythic server and with the web interface. And what you do with these when you're working on payload types is you actually define, configuration options and then the actual system commands used to build the payloads. And so you'll see that gives you a lot of control over exactly how you compile things. Do you want to include or exclude sections of the code before you build it? Do you want to, perform obfuscation at build time? All these different things. It also offers interchangeable network profiles. So the Mythic server itself only speaks one sort of language that implants could talk to it over. And so what is intended to be used are these sort of middleware, almost like redirectors, basically, that sit in between the Mythic core server and implants. And these network profiles can be a variety of protocols and are independent of the core server. So you can add new network protocols to the framework without touching the core code, which I think is pretty cool. And then finally, as you might be like picking up on from this, is that it's very modular. And so each of these components can be switched out and new ones can be added very quickly. And sort of you can sort of pick which components and which pieces you'd like to use on an engagement or on an operation or whatever it is. And so it's my opinion that this like modular nature is what makes Mythic sort of the like next evolution of what a C2 framework really is. So that's what I hope to kind of show you today.
Yeah,
so
it's pretty
just
amazing. I'm looking at their GitHub, Kyle. Like, it's an amazing application, right? I mean, there's a lot going on. They've got the Nginx web server, Postgres database, RabbitMQ, Redis server. There's a lot of traditional like application development components that go into this, which is pretty cool.
Right. And I'm actually going to go over those specifically
awesome.
in just a minute. No, that's okay.
Because it's good.
But it is cool.
I didn't know what Hasura was, so I'm hoping you can explain it to me.
yeah, I'll cover that briefly.
Awesome.
Basically, it's sort of like an intermediate layer between you and a database that sort of abstracts
database
specifics.
Yeah.
So you don't have to speak PostgreSQL, and theoretically, you could like switch out PostgreSQL for any database.
Love it.
And keep using the same queries and things. But yeah, so just real quick, I figured I'd do like, I wouldn't really even call this a demo yet, but this is going to be just me showing you what Mythic kind of looks like, and so you can get a general feel before we jump into it. So when you log into Mythic, this is what you're going to see. You've got all of these tabs at the top. You set an operation name, so I called mine Security Weekly. And you can sort of create things. So I can create a new payload if I want. I can view my active callbacks, which is where I would sort of manage the implants that have connected back to my server. And then here's where I can sort of manage like what payloads are connected. So you'll see I've got this Atlas payload and then this Scarecrow wrapper, and that's what we're going to talk about here in a little bit. As far as profiles go, we've got just an HTTP profile so that we can use HTTP traffic for egress communication. But yeah, so we're going to jump into this a bunch, but I figured just before I get too deep into talking about the components, I'd kind of give people a sort of like bird's eye view of what it looked like. So let's just jump back and we can talk about these components. So this is what we were just talking about a second ago. And this is kind of overwhelming at first. Like there's all these components. But really the key bits are on the far left, you see the React web user interface. And that is React, if you're not familiar, is a JavaScript framework for front-end development. And so that's what they wrote that web application that I showed you in. And that's where you sort of manage all of this. And that communicates with an Nginx proxy, which sort of gives you access to the core web server as well as a documentation server. So each payload contains a folder with markdown files. And if you browse to the docs page, you can see the markdown files sort of parsed and made to look nice. So you can read about how the payloads work and what commands they have. But all of this is stored in a PostgreSQL database. And the real key here, and what we're going to focus on a lot today, are these two sets of boxes on the right. So at the top, that is sort of the collection of payload type containers. And so each Docker container in that box represents a different implant that you could create executables for. So there might be, say, a Windows C# implant and a Mac implant that's in Python. And each of these have their own containers where you sort of interact and generate new implants from. And we'll talk about those right after this. And then in addition to that, at the bottom right, each of those containers is a network profile. So just like the HTTP profile that I showed briefly, those are the sort of middleware in between the implant. And you can see that, or hopefully you can see that small icon at the very bottom right. And that's the logo for one of the implants. And it sort of communicates through one of these Docker profiles, for example, the HTTP protocol. And then that is what's used to communicate back with the core server. And so you can see how the payloads and the network profiles are interchangeable and don't really impact that sort of center box that is all the core components of Mythic. And
so the containers, so Kyle, the containers at the top, that's where the payloads are like generated and stored. Is that correct?
They're generated there. I believe they're stored just maybe in the PostgreSQL database or somewhere that you can just download them from the web user interface. I'm not actually, they might just be stored in the file system, I guess.
Gotcha.
But the way that you grab them is just through that web interface.
Is that because they need a different environment to actually build the payload, right? Depending on what you're
building. And
building?
that's it. Yeah. So you give it just the tools it needs to compile or build or whatever your payload.
I gotcha.
And then just output some file.
And then there's a different set of Docker containers that do the TCP/IP communications from the C2.
Correct.
I'm like really impressed with their design, quite frankly.
I'm as well.
Or DNS or SMB, like, not just TCP.
Yeah.
Yeah. So they have an HTTP container. They have a DNS. They have a WebSockets. There's an SMB one, but I don't think it's functional at the moment. But yeah, they've got like lots of examples. And the idea is that you could write this for anything. If you wanted to add an ICMP one, you would just have to write something that took in ICMP traffic and converted that to whatever that central web server wanted. And then, any implant that you implemented ICMP traffic with should work with this framework.
It's an amazing architecture. I really like it.
I 100% agree. At first, it's sort of like a lot to take in, especially as you start working with it and you have to figure out like which components you're working with.
It's like an enterprise, like this is how a lot of folks design an enterprise level application.
Mm-hmm. Yeah, definitely a lot of thought went into, and they've like sort of refined this over time. Like some pieces are new and some things have been removed.
Yeah, like what is the SANIC web server? What is that?
So SANIC is a Python web server, so it's like a Flask replacement.
Okay. Yeah,
I think
Flask
that was like the developer's preference.
I develop in Flask, and it's really dated.
Yeah, so SANIC, I mean, I'm assuming from the name that it's meant to be a pretty lightweight and fast web server, but I honestly don't know a ton about it.
Gotcha.
But and that's the nice part about Mythic, right? Is that you don't have to know anything about how the like core C2 server works to add things to it.
Right.
And that's where I feel like with other frameworks, you have to come in and make all these changes to the core code that might break things that other people are working on. Whereas here, you just make changes to these, outside containers for what you want it to do, or you add new ones for new functionality, and it won't impact anyone else using the framework, which is pretty cool.
Yeah, it's pretty slick.
So kind of jumping into payload containers and C2 profiles. So payload containers, they are totally freestanding. So each payload type container is totally separate from the others. And it alone builds the payload. It has no external dependencies, which is kind of the point of a Docker container, I suppose. Mm-hmm. But they have examples of these. There's a couple C# payloads. There's a PowerShell payload. There's Golang payloads. There's Python. There's a NIM payload. So they have so many examples that either the core developers have made or just people in the open source community have made, which is really cool to see. People kind of contributing things to this. And so there's a Mythic Agents GitHub page that is separate, and that's where you can find all of the publicly available implants for Mythic. And same thing with the C2 profile. Those are also, I believe, on the Mythic Agents page. And so they've got the HTTP, they've got DNS, they've got WebSockets. I think there's others, like one or two others that I'm not remembering off the top of my head, but those are like the core C2 profiles that they offer. But yeah, so like with this, I guess, I don't know, let's just jump in. There's not much more to say on that. So in like a perfect world, right, you would make your own payload from scratch. And that would be really cool because you'd have something unique and it wouldn't be as signatured and all these things. But that takes a lot of time and a lot of effort, and might not be practical for every situation. And so one thing that I find really useful is just sort of taking these publicly available payloads and modifying them to have new functionality or to remove functionality I'm not going to use. So, excuse me. So as an example, the Atlas payload, which we're going to use today, is a C# payload, and it is, I think, their simplest one that's publicly available. So it's nice because it has a very small code base to go through to understand it. And you can kind of see some of these method implementations, such as print working directory and change directory, how simple these really are. All you're doing is passing whatever, output text you'd like into this job.response variable, and then you're setting job.completed to true. And once you do that, the next time that it checks in, it's going to send that data back. And so whatever text gets returned, at least in the first case, by directory.getCurrentDirectory, will just be shipped back as text and will show up in the operator's command line. The second example for CD has a little bit more, code to it, right? You're passing in the job.parameters variable, which is just anything you pass after the command CD gets passed to this variable. It's going to check if it exists. If so, it's going to just change the directory of the program and then return sort of a message that tells them that it was successful. But you can see, like, this isn't overly complex code. And so if you wanted to take Atlas and fork it and add new methods or remove things you didn't plan on using, it's pretty straightforward to get started with. There's not like a ton of
the output
abstraction.
The output of these functions and stuff ends up in ultimately in the React interface, right?
Exactly.
Gotcha. That's cool because that saves you from writing a whole bunch of code and just focusing on the actual payload functionality.
Exactly. And so you don't have to be a web developer and an API developer and a systems programmer to write a C2 framework now.
Right.
You just have to know how to make the payload. Or if you prefer, maybe you want to use an existing payload and you just want to write a network interface. But all that being said, you can just write one piece and use the framework in a new way, which is kind of cool.
Nice.
So in addition to the agent code there's also these Python scripts that we've been talking about. And so the core file in all payload types is this builder.py. And this is where you define how the payload is built and also what options need to be provided by the web interface. And so you can see here, I screenshotted a couple of options for Atlas. On the left, this is where you choose which .NET framework version to use, whether 4, which is sort of associated with Windows 10 era, and 3.5, which is associated with Windows 7 era. So you sort of choose this with a dropdown. On the right, this is like the chunk size for how big of a portion of files to send back and forth at a time if you're transferring things. And this is like a string input. So you can see between these two things, you could basically take in any data from the user. Do I want to drop down where I sort of force their hand, or do I want to just take any arbitrary data here and try and use it? And so it's pretty easy to define these. You just sort of, add to this array of things, and now you've got more options. So
that's really cool.
I've actually forked Atlas, and so I have this branch of it called CEX, and this is where I take ConfuserX, which is an open source .NET obfuscation tool, and I've added this as an option. So you can see on the right, I've got obfuscate as like a drop-down, true or false, and if you put true, it will build the payload and then run it through the obfuscator in that same Docker container. And on the left, you can kind of see the code that I implemented to do that. Basically, it's parsing this sort of definition file, and then the core of it is it's going to run confuser.cli, targeting that template file, which gives it all the options that it needs. So with this, I've added,
did you have to
like 20 lines or less?
Did you have to modify the Docker config to build the container to have the confuser built into the container, or does it?
I did not. All I did was I took ConfuserX and I put it in with the agent code.
Okay, gotcha.
And that gets like copied in or mounted in, I'm not sure, into the container.
Gotcha.
So that it can access all that.
So they even abstracted some of the container building away as well.
Oh, yeah. So most of the container building, you don't touch at all. You'll see, I think a little bit later, they've got this Mythic CLI binary that's made to sort of control the state of containers. So you're not ever using like Docker commands. You occasionally, like if you're building a new payload, you will have to define a Docker file, but they have Docker file templates. So you use like the Python or the C# or the Golang Mythic Docker template. You basically just say from that, and that's about all you need most of the time.
Oh,
and
I
so
see. Yeah, I saw
much
some
of
of
the
that in their
work is
GitHub. Yeah, they've kind of abstracted, so you don't have to do all the heavy lifting of building your Docker
Exactly.
containers from scratch. Yeah, it's nice.
Yeah, so that's really convenient too, because again, why should you have to know how to use Docker to write a malware payload? Like, those are sort of unrelated things, and while they are necessary, it'd be nice if it could be abstracted for you. Okay, so with this, let me go ahead and show you kind of how this Confuser X thing works. I've got my fork of Atlas in here. So when you want to create a payload, you go to the top here where it says create components and create a payload. And the first thing is it's going to ask you to select an OS, which we only have payloads that support Windows imported, so it's only going to give us Windows as an option. We then select the C2 profile. I've got sort of a hard-coded options here, so I don't have to set them all, but here's where you can set like the IP and the port and some encryption options, as well as modify like how the network traffic is going to look.
Mm-hmm.
The HTTP profile doesn't give you a ton of options, but they also have this dynamic HTTP, which is more like the traditional malleable HTTP profile. But that is not supported by Atlas. So we're just going to go ahead and use those. I'm going to pick Atlas as the payload type, and this is where you get those options that are defined in builder.py.
Mm-hmm.
So you can see here I've got obfuscate payload with Confuser X now as an option. I'm going to leave that as true. I can choose if I want an exe or shellcode. For now, I'll just do an exe. And then I'll just call this like Atlas cx.exe. And once I hit next, this is sort of an interesting bit. I kind of touched on this. Atlas doesn't support this, but other payloads such as Apollo for Windows do. This is where you can actually select which commands you want to include in the implant. And it uses sort of compiler directives to literally comment out code that you don't want. And so your implant is smaller if you deselect things, which is kind of cool.
That's slick.
But I hit create here, and I'm going to get some sort of status notifications that it's being created. I can click here to go to the payload management page, and you can see it being generated. These are a couple I was doing earlier to sort of make sure it all worked. But so here's my new payload, Atlas CX. And if I download this, it's probably going to get flagged by Defender just based on the assembly info and things.
So wait, Kyle, you didn't have to write any JavaScript for the React interface. It takes care of all that for you.
I have written no JavaScript.
Yeah.
Only those Python things. Yeah. As long as I've been working with Mythic, I have never written. I say as long, it hasn't been that long, but all the stuff that I've been doing, I've never had to write JavaScript. So.
Don't jinx it.
Yep, we're happy. We're happy about that.
But yeah, so this is where now you can just download this, or as you'll see, you can sort of use this in other functions in the web interface. So this is where like wrapper payloads will come in later. But let me go ahead. I'll try and download this. If it gets flagged, I'll just disable Defender. But later we'll have a payload that we do not have to disable Defender for.
Even better.
I could find my downloads window. Okay. Here's my downloads. So I've got Atlas CX. I'll get the smart screen. That's okay. Well, maybe. All right, let's jump to active callbacks. And look at that. We got a callback. So
nice.
I guess the Confuser X was plenty to get that past Defender, which that alone is like a pretty convenient feature.
Yeah.
That now you're not doing this obfuscation locally. It's just, one less thing you got to deal with. But so you can see, this is like your traditional sort of C2 looking interface. You've got some information here. I can click here and I've got my sort of, shell like interface where I could type PWD if I wanted. And it's going to check in every 10 seconds is how I have it configured. And then we'll get that information.
So now we're building a botnet. Yay.
And so there you go. I'm in my downloads.
What do you see as some of the downfalls or gaps that Mythic has in comparison to some of the other C2?
Sure. Yeah. So especially when I compare it to something like, Cobalt Strike or, a very mature framework like that, the Mythic agents that are publicly available, like Atlas and Apollo for Windows, are not really meant to be, I guess, OPSEC safe is kind of the best way to say it. They weren't really developed to be usable implants for, covert operations. They're meant to be sort of proof of concept things mostly so that you can go develop your own based on them. And so the usability out of the box of Mythic is a lot lower than other frameworks, I would say.
with some of the customizations, though, you can change that obviously and get things like the execute assembly, handoff, process injections for other beacons or callbacks or other implants, right? Just like any other C2 is all dependent on the customization.
And to be fair, like Apollo in particular has all of that capability. Like, and I mean, Atlas has a lot of it as well. Atlas will execute .NET assemblies. Apollo will also do that. It has injection. It has quite a few features just like that. It's just they're not really written to be difficult to detect necessarily. They're written to work consistently and to give the operator a lot of like understanding of what they're doing. It is kind of their goal so that they can use it as a reference. But they do have fully featured implants that do work in a lot of environments. And it's not something that like is unusable by any means. They're extremely stable and they have tons of features. It's just if you're going up against, in like sufficiently advanced blue team or even security products, you're more likely to get caught with those than you are other things probably. All right, so jumping back in, let's talk about wrapper payloads. I've kind of hinted at this a couple times, so let's just talk about what these are. So wrapper payloads, at least as far as I know, are a feature unique to Mythic. I don't think there's other frameworks that really do this. The closest thing is maybe Artifact Kit in Cobalt Strike is kind of like this, but I think wrapper payloads, like as a concept, are unique. So wrapper payloads are built just like normal payloads. You have to have agent code. You have to have builder.py. The only difference is that they take an input file from Mythic. So you give it another payload as input. And so, as we saw, a payload is just an arbitrary file. So it's not necessarily an executable like we saw. It could be shellcode. It could be a script. It could be a picture. It's whatever you define, really. But typically, it's going to be an executable or shellcode. And so I made this like very generic flowchart, and then I've got a more specific one on the next page. But basically, your payload type container on the far left will build a payload and output this shellcode or executable probably. That will be used as input for a wrapper payload. This wrapper payload does something with that file and then outputs another file. And so that's very vague, and it's kind of vague on purpose so that you can do a lot with it.
Well, it's really just like nested payloads, right? Like you have a Python.
You don't have to put the payload in the final result, though, right? You just have to. You don't have to use it, but the intention is you take that payload in and you do something with it, and then you output something different. Right. You could have wrapped it. You could have pulled something out of it. You could have done anything with the input file. But yeah, a lot of times it's going to be wrapped shellcode in some way.
Right.
So their example, and I think the only public example before mine, was a service binary wrapper. So you would give it shellcode from Atlas or Apollo, and it would give you a binary that could be used for a Windows service target. So you could replace the binary of an existing service, or make your own service for persistence, or maybe a PS exec type lateral movement or something. But one way or another, you're going to wrap this shellcode in a service binary, and now you have this new file that isn't just a normal executable. It's a service, and it calls that shellcode. But to sort of extend that, right, I've written this tool. It's called Scarecrow Wrapper. If you're not familiar with Scarecrow, this is not a tool that I wrote itself. I just wrote this for Wrapper. There's a guy, Tylus, on Twitter. His name's Matt, and he wrote this sort of implant generation tool, or implant loader tool, really. And what it does is it's going to output an executable of some sort that wraps shellcode. So they come up with some kind of Golang payload. It can be an exe, a DLL, an Excel file, an MSI, a CPL, and it's going to output this and do all of these kind of evasion techniques to try and bypass and unhook EDR. And I know a lot of testers who this is like their primary shellcode loader that they use pretty effectively. And so it's definitely an effective payload. And so Scarecrow is great, except to use it, you have to generate shellcode in Cobalt Strike or whatever framework you're using. You have to download that shellcode file. You have to download Scarecrow. You've got to build it and make sure that you have all the dependencies and things correctly. You've got to remember all the command line flags for Scarecrow, or you've got to read the README. And not to say that that's like impossible, right? That's a lot of what I do is remembering how to use tools and installing them and things. But it's just one more step for an operator that some people just maybe don't have the time to do if they're time boxed on an engagement, or maybe they want to try a few different tools and it's sort of inefficient for them to keep downloading new ones if they have one that works, and so they may never even try Scarecrow if they have another one that they like. So
yeah, but also a manual process like that is error prone. So
of course, yeah. And you can make mistakes. You might, have some weird version issue that breaks the payload. Like there's a lot of issues that you have. So what I've done is I've made this wrapper payload that basically you build Atlas and you output a shellcode. So instead of exe like we'd select shellcode. You go to the Scarecrow wrapper generation page. You target that shellcode. You choose the options out of drop-down menus, and then it just gives you this executable in the web browser. You haven't downloaded anything yet. You haven't installed anything. This is all happening server-side. Even the payloads are stored server-side. So you're not touching anything on your local machine yet. And so if this is like a group type engagement where you have multiple operators working, they can see everything that's happening there. They can all download the same file. And there's no like weird, oh, hey, can you generate a new payload for this because I can't get it working? Or, oh, can you use Scarecrow because I've never used that? It's all in the web browser and it's all happening server-side, which is really nice. So let's jump into that real quick. So if I go back to payloads here, I guess payload creation, this is the successful output from that. If I go back a page, I've still got all the same options selected from before, which is kind of a convenient feature of this build page. And now I can just select shellcode instead of WinExe. And we'll just call this Atlas SC. And I'll make the extension .bin just to be clear. We can't deselect anything here, so we'll just click create. So that'll start creating. And if we go to the payload management page, we can wait for this here for a second. All right, once that is done, we jump to create wrapper now instead of create payload. So create wrapper, we're going to select Scarecrow wrapper. It's the only one added. And this is where we've got a bunch of options that Scarecrow supports. And it's essentially going to just pass these to the Scarecrow tool in that Docker container. And so you don't have to worry about knowing the options or what they do because it's all right here for you. And so we'll do the control file. Sure, we can patch ETW. We don't necessarily need console output. We can't use sandbox in this case because I'm not domain joined. This is only for DLL payloads. And then for a website, we can just do Avery.com. And so I'll do next. We'll target the Atlas SC.bin, which is the one I just created. We'll call this Atlas Scarecrow.cpl, which is the control file extension. And we'll go ahead and create that. So let me jump back here. We'll let this create now. Roll. But yeah, so once this is ready to go, we can go ahead and download here. Go back to our downloads. We've got Atlas Scarecrow.cpl. It's this control panel item format. We go ahead and double click this. We're going to get Smart Screen because we just downloaded it. We'll go ahead and run it though. And then we'll come back here. And if we jump back to our callbacks, we've got a new callback, callback 3 in this case. That, again, same kind of process, but now we've got this payload that not only was the .NET assembly obfuscated to begin with, so all the method names and things have been changed, but then on top of that, we've wrapped it in Scarecrow to give us this sort of payload that unhooks things and makes it very difficult for security products to monitor in the first place. And then theoretically, even if they did find some piece of our payload, it's been modified from the original. So you can see how, I'm using sort of two different sort of add-ons, I guess. I'm putting Diffuser X and then Scarecrow, but theoretically you could chain as many things as you could imagine here. You could have wrappers that obfuscate it in different ways, or that maybe, pad or change the shellcode output, or you could have wrappers that, to give you different stage 0 loader options for different alternatives to Scarecrow. And so, I don't know, I think it's pretty awesome that you can sit here and all in the web interface create all these things, and you're not, worrying about all these dependencies. So, like I said, wrapper payloads, they don't necessarily give you any new ability as an operator. They just sort of streamline things. So we talked about obfuscating payloads. You could use this for generating, maybe malicious documents for initial access, right? There are Python libraries for creating Excel and Word documents, and you could use those to create, new documents that have macros that call the wrapped payloads. You could even potentially, because these Docker containers have network access, you could call some external build pipeline. I mean, you could take whatever input file, push it somewhere totally different to another system, to a CI/CD pipeline, whatever you want. You could push them there, have it run some process, and then, use an API to pull whatever the result is back. And so you've got endless possibility really with these wrapper payloads, because as you kind of saw in that first diagram, it's just so arbitrary. Like, it's just take in a file, do something with it, give back a new file. And you can define this all in Python. So there's really like endless possibilities there.
You've been having a lot of late night conversations with Joff, haven't you?
Yeah, no, I definitely talk to Joff a lot about Mythic. And I think he's probably tired of me telling him about it by now. But
that's why he didn't want to show up tonight.
Right. I was wondering if he'd be here. I figured he'd be chuckling if he heard me talking about this.
Yeah, that build pipeline, he has all of that for offensive tools.
Mm-hmm. Yeah. So real quick, I'm kind of cutting close on time, so I'll just sort of breeze over this a little bit. But Terraform, if you're not familiar, is not related to Mythic. It's just a tool for defining infrastructure as code. And you sort of like define VMs and other resources, and you tell Terraform to go build it all. And so Terraform, some people will sort of cringe at me saying to use the SSH provider because they prefer something like Ansible. But in the case of Mythic, this really is kind of practical because of how simple Mythic deployment is. You can see here, this is really all that's needed to deploy Mythic. I'm installing Docker. I'm cloning the Mythic repo. I use that Mythic CLI binary I mentioned to install 3 payloads from GitHub, the Atlas, Apollo, and HTTP payloads. You could also, instead of GitHub, specify a folder, though, if you had a private repo. I define the credentials and the operation name I want to use, and then I just start Mythic. And it is a Docker Compose setup. You saw I had to install Compose as well. It's a Docker Compose setup, so there's really like nothing you have to install from a dependency perspective besides Docker and Docker Compose, which makes it really convenient to automate deploying this. Like, you're not worrying about, Dockerizing it or trying to find ways to wrap it in a way that automates it. You've already got that all done for you just by design. So that's pretty.
I will say, nice. I think independent of what Linux distro you're using, make sure you install Docker from their official repos and not using what's in the Linux distros, because it's typically outdated.
For Debian in particular, this does not work. Like, you have to add the Docker repos.
Yeah, and Docker and Docker Compose are 2 separate installs that you got to do separately. And like you said, Kyle, Debian or Ubuntu, you don't use what the package maintainers include.
No, that's a really good point. I sort of left that out just for brevity's sake, but that's absolutely true.
Yeah, otherwise you get people basically hitting the same problems we hit, because they're like, oh, it's included with the Linux distro. Cool, it saves me time. But no, now it's 3 times longer because now you have to uninstall it and reinstall it from the Docker repos. Yeah. Been there.
Oh yeah, definitely been there. Yep. So, barring that hiccup, it's a pretty simple process. Yeah. But yeah, installing Docker sometimes can be annoying. On top of that, Mythic, the web UI is actually just a REST API to add on to this sort of idea that they architected really well, right? The React interface is actually just hitting a REST API and pulling the data. And so you can actually write scripts that hit this same API to do anything you can do in the web interface. There's no functionality that is in the web interface that you can't interact with the API for. And on top of that, the Mythic project actually provides a Python library, which I'm using in that screenshot on the right, to sort of simplify script writing. So you can see I've got this, mythic.login function now, and I've got mythic rest.payload where I can sort of define a payload and then later say generate and download it. And so this becomes really convenient from an automation perspective as well.
Kyle,
because
they give you a Python library that interacts with their API, and that's the same API used by the React interface.
Correct.
Sweet.
And
how about that for your hipster technology, Tyler?
Definitely.
Tyler's
so you can
crap.
pip install Mythic, and I mean, you've got this available to you now, which is kind of cool.
It's awesome.
But so like I said, I'm going to sort of brush past that. All right, so this is my final section, is talking. I've got 3 use cases that I think Mythic in particular is posed to sort of solve or be a better solution for. So the first one, and this is something that I've heard from a lot of different testers at different places, is that Cobalt Strike is great and it has a ton of functionality, and it's just a really stable, solid tool. And because of that, there are actual threat actors using Cobalt Strike more and more and more, right? Half of the ransomware, or probably more of the ransomware things we hear about these days, are using Cobalt Strike. They've got cracked copies of it, and they're doing. And so security companies, all these EDR vendors and antivirus vendors, are disproportionately incentivized to detect Cobalt Strike. So they're investing a lot more money and time and resources into that than they are necessarily detecting, techniques. Not to say that they don't detect techniques; they absolutely do, but they're especially focusing efforts on detecting Cobalt Strike as often as possible. And so many companies have started looking at how they might make their own C2. They look at the available open source C2 options, and there aren't really a lot of things that are comparable to Cobalt Strike out of the box. Even Mythic, right? I mentioned that the payloads themselves are not as OPSEC sound as something like Cobalt Strike would be. And so out of the box, there just really isn't anything that is directly comparable to Cobalt Strike yet, especially not for free, but even paid that I know of. And so when companies look at this, though, they get in this sort of like problem where developing something that replaces Cobalt Strike costs a lot of money. You've got to have developers that can write APIs, that can write a user interface in some form, and can perform some systems programming to have some implant that interacts with API calls and things, right? So Mythic is, and I think this was the original intention, it is designed to solve this exact problem, in that it allows you to reuse the user interface and the API and even the HTTP and other network profiles and just develop a payload, which is still a sort of daunting task, right? But it's 1/3 of the task. Well, maybe not exactly 1/3, but it is a much smaller task than the three things combined, right? So now all you have to do is write one payload. They have docs that are specifically telling you how to write payloads for Mythic. They've got several example payloads in all these different languages for a bunch of different operating systems. And so that is I think their primary intended use case is that it really does solve this problem, hopefully, for organizations. Use case 2, and this is what I just wrote a blog post about, is the ability to have multiple stages of malware. Like, you have a stage 1 implant for initial reconnaissance. You've got a stage 2, a fully featured implant. You've got maybe your stage 0 loader, like Scarecrow. And it's nice because you can use Mythic to put all of that in one place. So you can generate fully featured implants. You can generate stage 1 implants. You can wrap those in shellcode loaders. And once these implants start calling back, they can all be sort of managed in the same web interface. So in this diagram here, you can see I've got these two different pieces of malware running on the same computer, stage 1 and stage 2. Stage 1 calls back through CDNA, let's say it's Azure, and that goes back to port 443, and we configure Azure to redirect that to port 9002 on the C2 server. And with stage 2, we do the same thing. We've got a totally different payload, and it communicates to a totally different CDN, say AWS, still over port 443, still with SSL, but then we instruct AWS to redirect that traffic to port 9004, something different. And so the Mythic core server, or at least that HTTP profile, can receive both sets of traffic and can differentiate them. But from like an IR team perspective, or from someone on the blue team looking at that computer, they look like totally different pieces of software calling back to different domains and IPs and using even maybe different network type protocols. So practically, these are totally different, implants entirely with potentially totally different backends. And so seemingly unrelated things are really being managed by operators in the same place, which is really convenient, I think, compared to sort of having multiple interfaces and, having to know two different tools or something.
This also has multi-operator interfaces, right? Where multiple operators can operate from the same Mythic server. One of the caveat other ones.
So you can have multiple operators with different permissions level, like admin and normal user, and you can actually have multiple operations running. So you can have two different operations that have their own implants associated with them and their own payloads generated and their own user accounts. So theoretically, you could run one Mythic server and have two different engagements running on it, and the operators wouldn't even know about each other, which is kind of cool as well from sort of an infrastructure perspective, maybe.
Two different operators pick up two different payphones and get sucked out of the matrix? Is that
Exactly. So finally, and this is kind of what we mostly talked about today, so it's quick, is just this ability to use all of these different tools and frameworks for modifying payloads in one place, right? You don't need your Scarecrow and your Confuser X and whatever else you decide to use all downloaded on every operator's computer anymore. You just put them all in the server side and you deploy it for them, and now they can go and use all the tools they want without installing anything or even knowing how to install them necessarily. So,
well, and it's a great point, because you've got multiple folks at BHIS that are kind of renowned, Joff and someone else whose name escapes me, that create their own payloads, and rather than managing it separately, they put them in this framework and you're off to the races.
Exactly. So like as it stands, right, if you develop a payload at any place, you've got to sort of like distribute it to people. You've got to teach them how to use it. You got to do all these things. Not anymore, right? Now you put it in here, you slap the React options there, and now when they go to log into their operator panel, they've just got drop downs and things, and suddenly they're using Joff or whoever else's payload without even knowing how it works or how to use it or anything really, which is sort of that I guess force multiplier of the team now, is you can have people developing components and helping everyone.
That's really cool.
So yeah, that's pretty much what I've got for Mythic. That was all I hope to convey today. So hopefully you guys enjoyed and maybe learned some stuff about it.
Oh man,
that's really
that was pretty awesome, man.
I mean, you must have fun teaching folks how to use this. I mean, I could see a lab in a class where you got one Mythic server just going to town on your targets.
Yeah, so in my Windows PostX class that I mentioned at the beginning, we're going to start using Mythic now. Previously, we used something else, and since learning about Mythic, I've switched it over entirely. And so everyone that joins is going to get to learn to use Mythic, and even like modify some existing payloads and things like that. So it should be a fun time.
Have you thought about incorporating, training, doing some blue team training, trying to see what you're doing?
Sure. So I mean, my specialty is definitely not in the blue team area, and so I definitely try and learn all that I can about it, especially with some of the like really skilled people in that area we have at Black Hills. But I don't think I'm nearly qualified to sort of teach anyone about defense or blue teaming at all at this point. But yeah, I think that's definitely a totally different, interesting topic that maybe one day I could teach people about. But
cool.
Yeah, it'd be pretty cool to extend the framework to automate some breach and attack simulation. I know it wasn't designed for that, but it certainly seems extensible enough and robust enough to be able to do that.
And one thing Mythic does do that I didn't really cover is any command you build into a payload, you can actually assign it attack IDs for the MITRE ATT&CK framework. And at the end of an engagement, you can actually pull up this sort of map that highlights which attack IDs you used on the engagement, which is a really cool tool to show clients and for them to even take back to their security vendors and say, hey, you caught these ones, but not these ones. What's going on?
Right.
So wait, are you mapping it to legit attack IDs, or are you using it as a deception technique?
Or legitimate attack IDs. So anytime you execute a command, if the implant has been written to support this, which a lot of the public implants have, in the framework, like in that web interface, it will sort of make a note that you use this technique or this attack technique at this time, and this was the command you ran. And at the end, you can sort of export this report that if you want to, you could give to the blue team or to a client.
Kyle, other than training, do you have any webcasts or any other things coming up at BHIS?
Nothing is scheduled at the moment. I just did a webcast, I guess, like a month ago. But otherwise, I'm kind of just focusing on some personal projects and things after this.
It's awesome. Kyle, you ready to play 5 questions with Security Weekly?
Oh, yeah, I guess so.
There's no right or wrong answer, and we asked these questions, same questions of all new guests on our show. So, Kyle, 3 words to describe yourself.
Oh, geez.
That's 2. Oh, I'm just kidding. Go ahead.
I guess I would say that I'm passionate, and I'm learning and I guess excited. Like, this is just stuff I like to do, and I'm always trying to learn more.
If you were a serial killer, what would be your weapon of choice?
Ooh. I think you got to go with the ice knife, right? Or that's like the classic.
Icicle, that's classic. Yes. If you wrote a book about yourself, what would the title be?
Oh, geez, wouldn't be much to talk about. What would a book about me be called? Something with short story in the title, because like I said, I'm still pretty young, not a whole lot to write a book about.
Kyle, what is your favorite hacker movie?
It's got to be Hackers. That's definitely
all right.
a great
Vote
one.
for the Hackers Camp. Jeff, he's not here tonight, but we have this kind of running game where I'm in the Hackers Camp. He's in the sneakers camp. I like sneakers. I just think Hackers is my number one choice. So I'm with you.
Hackers is great. Yeah.
Kyle, choose 2 celebrities to be your parents.
Alive, dead, fictional, or otherwise.
Gotta be Keanu Reeves, just because the Matrix. Let's see. Other parent? Maybe Trinity, just to keep it sort of in the same theme.
All right. There you go. Use the term operator a lot, so I can tell you're a big fan. Although I think that movie came out before you were born, but
maybe I don't know what year it came out, but I did grow up watching that.
It was 99. I believe it was 1990. Was it 99? Was The Matrix 99?
I was alive in 1999.
Barely.
Yes.
Hold on. Now I got to look that up and see if I was
1999.
Right. It was 1999. There you go.
Fun fact: I might be in the background of Matrix 4. I was in San Francisco when they were filming part of it, and like we were sort of in the back when they had a whole scene going on. I didn't realize it at the time, but
that's awesome.
Come to find
so
out,
you might be an extra. That's
there's a
amazing.
chance.
An extra.
An extra.
Extra, yeah.
Sweet. Kyle, thank you so much for appearing on Paul Security Weekly.
Yeah, thank you guys. It was great to be here.
Coming up next, the security news. Stay tuned.